Hey, welcome back to our demonstration of creating a dice game, the Yahtzee game. If you remember last time in part 1, we created a class called Douse, which was meant to represent a single dice. And the Douse had two properties, a number of sides, and a top number, which is the number that it's currently showing on top. And we created an initializer that let a user create a dice with a certain number of sides on it. And we also gave it a behavior. Each Douse has a behavior that it can be rolled, where a random number is chosen for the top number. Okay? Now in today, and then we tested it here with a short little main program that created a Douse with 6 sides, and we made a for loop that rolled it each time 100 times, and then we showed the number that got rolled each time. So today we're going to extend this by creating a new class that uses this class. Okay, and this class, because we're creating Yahtzee, which is a dice game, I'm going to get rid of all this code here from here on down, so we can start with just our class. Now, Yahtzee is a dice game, and there are certain behaviors and certain properties that all dice game have. So again, we should try to make this as general as possible and not specifically make a class for Yahtzee, but let's start by making a class that all dice game could use. So something like Monopoly or Dungeons and Dragons or Clue or whatever could use this class. Okay, so we'll say class dice game. Okay, now in any dice game we should think about the kinds of things that a dice game might have, the properties of a dice game. So let's think about two different dice games. How about Monopoly and Yahtzee? Okay, Monopoly, there are 2 6-sided dice, and you roll them every so often. And Yahtzee, there are 5 6-sided dice. So probably one thing that a dice game should have is a property that tells you how many dice are used in that game. Okay, so let's make one of those. Var maybe number of dice used in the game, and let's set it to 2. Even though we'll probably make an initializer that will let us set that to some other number. But a lot of games have 2 dice in it, so that's a good default, a good value to initialize it to. Then, not only do we need to know the number of dice, but every dice game needs to have some kind of a representation of the collection of dice. So we're going to need to, if we've got 2 dice, say after we roll the 2 dice, we're going to want to ask those dice, what are your top numbers? Or if we roll 5 dice in the case of Yahtzee, we're going to want to ask things like, do all 5 values match in your collection of dice? So we need a way to represent that collection of dice. And remember when we talked about collections of instances, we talked about this idea of an array. So here it might make sense to have every dice game might have an array of dice, either 2 dice or 5 dice or however many dice are being used in that game. We're going to need to access the information from those dice. So here's another property, and we're going to call this property dice. And dice, its type here, is going to be an array of what? Well, each dice is going to be an instance of Douse. So this collection will be a collection of Douse. So let's say, here's how you make an array syntax. You say Douse, like that, an array of Douse. And let's go ahead and create an instance of that. So to create an instance of that, we say Douse, open, close parentheses, like that. So we're initializing it to an empty array of Douse right here. Maybe in our initializer, we'll go ahead and create those dice in there. All right. So let's do that now. This is probably enough. If we need more properties, we'll come back and add them to our dice game. But for right now, let's think about how we want to be able to create a dice game. So one thing we're going to want to be able to do is ask, how many dice are used in here. So maybe initialize with number of dice, and that's going to be maybe say n, which is an int, something like this. Okay, so we can make a new dice game with number of dice 2, for example. Okay, so when we do this, the thing we probably need to do here is, first thing we'll need to do is set our number of dice to be n. So let's do that. So number of dice will be equal to the value n that we pass in, right? And then, a little comment in here, create n dice, okay? And put them in our array. All right, so that's going to be a for loop to create all these dice. So we'll say for I in 1 up to number of dice. For I in 1 up to number of dice, we want to create a douse. And how many sides do we want to give that? Well, in our game right here, let's go ahead and we'll change this later, but let's go ahead and say that we say with sides 6, because we're going to be creating dice for a Yahtzee game, so they'll all be 6-sided. But I suppose we should probably change this eventually, and we will, our init to take a number of dice and a number of sides in here. In fact, let's just go ahead and do that right now. Let's go ahead and do that right now. So our initializer to create a dice game will give a number of sides and a number of dice. So we're going to say create a dice game with number of dice 2, and let's say with sides m, okay, where m will represent the number of sides that we have. Okay, so now in here we're going to say create a douse with sides m. Okay. So we're creating number of dice, all with a number of sides m in there. And after we create each one, we can't forget to add these to the dice array up here, to the dice array. So here we'll say dice.append, and append is a way you create a new element and add it to the array. And the one we want to add is the one we just added here. Oops, a douse. We want to append a douse into the array. So we go through here, we create an instance of dice, and then we add it right in here to the array. All right, that should be all our initializer needs to do at this point. Now let's think about behaviors for this class. So a dice game, probably the most important thing it needs to be able to do is roll the dice. So here's our first behavior, roll dice. It's a function, and the function is going to go through all dice and roll them. Okay? All right. Now our dice, remember, are represented in this array here, so we can use that cool way in a for loop. We can do something like this, where we can say for a douse in dice. That's going to go through every douse in the array dice, and all we want to do is say, hey, a douse, each one of you roll. So that will roll all the dice. Okay, I'm going to actually get rid of this comment because I think it's pretty clear from our code what this is doing in here. It's just going through all the dice and rolling each one. Okay. So looking good so far. Let's go ahead and maybe make a maybe test this out now. Okay, let's create a dice game here, and let's start by doing this. Var Yahtzee equals a dice game, and our dice game takes two parameters. The number of dice will be 5 with sides 6 in each one. Okay, and then what I would like to do is something similar to last time, where we do something like this. For something in 1 to 100, I would like to roll roll the dice. Yahtzee.roll dice. Yahtzee.roll dice. And then I would like to show all the values in here. So I want to say show all the values of the dice. So we could in here try some things like, we could get all the values in here by saying, dice 1 is equal to, and then in here we would say Yahtzees dot dice at index 0s dot top number. Okay, and then do the same thing for dice 2 and so on each time. But boy, that's going to be a long statement. So we need a better way to do this. But I will run this, and let's just look at the top numbers of the first dice in here and just make sure this is working out fine. Okay, so dice 1 is going fine. We could do the same thing for dice 2 and so on. So just to let's really quick copy this, and let's just put this right after here to see. I'll paste this in here, and we'll change it to be dice 2. So we're going to print dice 1's value, and dice 2's index, of course, is going to be 1. And let's see, we're getting random values for 1 and 2. Yeah, so that's looking good so far. But I would like, as this is kind of ugly here, there's a lot of code in here to show this. So I'm going to show you maybe a different way to do this here. What if we were to, as part of our dice game, let me pause this, as part of our dice game, since a lot of times you want to see what the values of your dice are, you want to show that to the user, right? But what if we were to come in here and say one of the behaviors of a dice game is that it can show you a string representation of its dice at any time? Okay, so let's do that. Let's say func string representation. So and that's going to be a function, and this function is going to return a string. So remember, this is how you say return a string. Okay, now the string we're going to do is, let's just make one here that we're going to return. So var new string equals an empty string, so it's going to be empty. And then as we go through, we're going to go through each of the dice and concatenate its value, a string representation of its value, right into new string. And then at the end here, we will return new string. So down here at the end here, I'm just going to say return new string. But before we do that, let's do a for loop for a douse again in dice. We want to concatenate onto new string. So let's say new string dot append, and the thing we want to append on here is, maybe let's just say let's do a douse's dot top number, a douse's top number, and then we'll put a comma after it and a space, and that's it. And maybe at the beginning here, instead of initializing our new string to be an empty string. Let's give it one of these curly braces. So it's going to, the string we're creating, the string representation we're creating is going to have a curly brace. Then all the top numbers followed by commas and a space. And then at the end, let's go ahead and say new string append, or another way you can append is by doing this, plus equals a final curly brace like that. And then we'll return it. Okay? So that's our string representation. It returns a string, so what we can do here is instead of showing all this stuff in here, let's actually show Yahtzee dot string representation, because that's a string, and that will hopefully show us a string representation of each of the dice. Okay? Let's take a look here and see what happens. There we go. We got all 5 dice in there. Oh, that was almost a Yahtzee up there. There were 4 6s. Okay, remember a Yahtzee is 5 of a kind. 5 of a kind. So let's do that here. Let's actually check in here as we roll through here. When we roll the dice, we'll show the dice and we'll do something like, say, if it's a, we'll say is Yahtzee. No, we want to ask this about our Yahtzee game. Yahtzee dot is Yahtzee. Okay, and that's going to be a function that tells us whether all 6 are the same or not. Okay, then we want to show, yes, I win. Something like that. Otherwise, we're going to show a message that says something like sad, trying again. Okay? Now, we don't have this function is Yahtzee. That could be part of our game here. That could be part of our game, but I'm thinking that we probably want to modify this a little bit, and let's go ahead and do that here. Let's not call this is Yahtzee, but instead we'll say something like all top numbers equal. Okay, all top numbers equal, where that's going to be a function in here, func all top numbers equal. Now, what does all top numbers equal mean? Well, remember a dice game could be any dice game, Monopoly or Yahtzee or anything like that. And in Monopoly, for example, there's a special thing called doubles. When you roll 2 dice and they're both the same, that's called doubles, and you get to go again, and some other things happen with that, right? And that's one of these cases where all top numbers are equal. Both of the dice are equal. In Yahtzee, the same thing happens. If all the dice, all 5 of them are equal, that's another special thing that happens. So this is a good function to have in a dice game, in a general dice game, is this idea of all top numbers being equal. So how should we write that? Well, first of all, that's going to return a Boolean, right? That's going to return a Boolean, whether it's true or not. Okay, so return a bool. And one way to do this is to say maybe something like, well, let's like assume that it's, true that all are equal. And if we get all the way through looking at each one of them, if they're not all equal, we'll return false sometime. But if we get all the way through and they are all the same, then we will return true. So one way to think of this is maybe, if all are equal, then they all have to be equal to the very first one, right? To the very first douse. They can't all be equal if they're not all equal to the first one. So maybe a plan might be to say, let's grab a hold of the very first dowse, and then let's check every other dowse against that first dowse and see if they're all equal to that first one. If we ever find a case where one of the dice is not equal to the first one, we know that it can't be doubles or it can't be a Yahtzee, and we'll return false. But if we get all the way through and we don't find a case where one of them is not equal to the first one, then we know they must all be equal, and we can return true, that all top numbers are equal. Okay? So let's do that. Let's create a constant up here that's called maybe first dowse, and we'll set first dowse equal to dice at element 0. That's our first dice, right? And then let's loop through all of our dice. So for a dowse in dice, then we should check if a douse's dot top number, the one we're looking at now, is not equal to first douse's dot top number, then we know that we don't have all of them are equal, so we can return false. We know they're not all equal. But if we get all the way through this for loop right down here, and we haven't returned or exited, because what happens is when we say return, we exit out of this function. So if we get all the way to right here and we haven't exited, that means that we've made it through every one of these dice, and they're all equal to first dowse. And if that's the case, we can return true at that point. That'll be very rare, because Yahtzees are very rare, especially in a game with 5 dice, right? In a game with 5 dice, you very rarely get a Yahtzee. So, but maybe let's test this out here. Let's pretend Yahtzee is now not a game with 5 dice, just to make sure this happens. Let's say it's a game with 3 dice with 6 sides, okay? And then here we want to say if Yahtzee dot all top number, I want to fix the name of this, all top numbers are equal, and I need to fix it up here then too. All top numbers are equal. Then we're going to show yes, I win. Otherwise, if it's false and they're not all equal, we'll say sad, trying again. Okay? All right, let's try this. Just a review here. What's our function all top number equal do? Well, it first assigns a constant first dowse to be equal to our very first dices, our very first dowse. And then it looks at every dowse in our collection and it checks, is the top number of each of those dice not equal to first douse's top number? And if any of them are not equal, we exit out of here right away and we say, oh, that's false. But if we get all the way through and we've never found a case where one of the top numbers is not equal to the first douse's top number, then we know they're all the same and we return true. Okay, here we go. Let's try this with 3 dice and let's see what happens here. Okay, a lot of sets. Hey, there's one, 6, 6, 6. Yes, I win. Otherwise, a lot of sad trying agains. Oh, there's one, 4, 4, 4. Yes, I win. And if I get another one, I'll stop it. Okay, getting a Yahtzee is pretty rare, even with 3. There's one. There's one. So when it rolled 3, 3, 3, it says, yes, I win in here. Okay? All right. You can try it with 5 dice and just see how rare that is. Actually, one good idea, if you want to try this at home, is inside this main program here, make a counter and see how many rolls it takes you until you roll a Yahtzee. Okay, until all 5 dice have the same value. You might have to make your number go bigger than 100, maybe 1,000 or something like that. But go ahead and, if you want to extend this activity here, just make yourself a little counter variable, and every time you roll, make that counter increment by 1, and maybe when you do find a Yahtzee here, stop the loop or something like that, or print out what the value is of the counter to see how many times it took you to roll before you got a Yahtzee. That's an interesting idea to try out. But for us, that's going to be the end of our part 2. We've got a nice, pretty much a good Yahtzee game here, because we've got a dice game that we can create a Yahtzee game out of. And next time what we're going to do is, instead of printing out the values here, we're going to start building our user interface for our app. And we're going to have a button that lets us roll each time, and then it's going to check whether we have a Yahtzee, and it's going to display what we rolled, and maybe we'll have some images of dice that show the right numbers on each of the dice. And then when we get to a Yahtzee, we're going to have a special message pop up and say, Yahtzee, you win, or something like that. Okay? So join us next time. We wrote a nice class here called DiceGame. Its properties were the number of dice in the game and a collection or an array of douse to represent each of those dice. And then we've got an initializer that takes 2 parameters, the number of dice in the game and the number of sides on each dice. And then, of course, we've got some behaviors like roll the dice, give me the string representation of all the dice, and check if all numbers are equal. So, all right, good job today. Join us next time in part 3, where we'll start adding the user interface. See you then.